First of all, let me introduce the following notation. For any great R, not in R, I will use the notation to denote the category of groups. The R is anyway. Let me recall that the words formal group are understood in the more classical sense. In particular, they are supposed to locally on the base. The formal group is supposed to look like a formal politics. In this sense, the formal group is small. And this is why I use the notation. Now, maybe a more serious justification for the dimensional data is that if R then this category is naturally represented of the categories which can be known by n. Small n stands for the category of n smooth. This category is defined only if for finite n, this category is defined only if R is over E. And by definition, small n and B and smooth mean that B is a base scheme. Our group scheme looks like the n Frobenius neighborhood inside politics. You mean a smoothism of stats? Now, as far as I understand, so this is not about what I said, but what it is. Was your question about the form? We assume that R is variable and consider small n as a counter with various categories. Considers a counter with various group forms. Then this is of course a step. It's easy to see that the step is function. Then the question is whether this step is correct and whether the transition morphisms are smooth. Now, if n equals 1, then I give an explicit description of 1, which shows that the step is smooth. If n is greater than 1, then one has to work. And last year, the situation was as follows. Last year, the step was smooth, and the transition morphisms were also smooth. But I forgot whether this rules or just free. But for now, it doesn't. Now, the next topic that we want to consider is the problem. I will discuss a moment of contrast from from the category of individual groups. In the category form. And it's defined only if R is means that somehow P is This concept is in some sense easy to define. Just given a indivisible group, you can solve its condition. And I will recall what it means. But anyway, from this, a priori, we see that this G hat is an instant. It's not immediately clear that this instant is a form of both in our what does the word completion mean? G, our G, it's a divisible group, so it's a union of its n-Truncated Barsotti-Tate groups. And if you wish, a definition or other observation is that the form of completion is just union in the form of completion. And for fixed n, the n is just a scheme, not a form, not a scheme. And in this case, we know a lot about what formal completion means. This is the union of invisible neighborhoods. You know, in K means the case invisible neighborhood, the zero section inside G. In fact, a coupled union. And now there is this theorem. Which says that if the formal completion of this group is a formal since we have a group structure in G hat for free, the true statement is about how G hat looks if as a scheme or if only as a base. Statement is look in the base, it looks like that formal polygon. Now, before I started preparing these lectures, I had two misconceptions. One misconception was that this theorem is pretty obvious. And the other misconception is that this theorem was proved by Tate in his original paper on P-division. Well, in fact, the situation is as follows. If we know a priori that G comes, let's say, from the P variety, then the statement is indeed difficult. Also, in general, it's not quite. The proof has several steps. And also it turns out that Tate proved the statement assuming that R is active. And his argument doesn't seem to work in in fact, this theorem is proved in Mason's lecture notes, and this book by Mason is available on the seminar website. Now, I will prove the theorem is if R is characteristic. I will not discuss the proof in general, but maybe I will send you after. Maybe I will send you an email with some words about this. So the good, as I said, G flat will be bigger. G n hat, and G n hat is by definition the union of infinitesimal vector. But if we are in characteristic P, we can also write Gn as the union of Frobenius neighborhoods. I wish I mean to take Frobenius the kernel of by definition, the kernel of the K power of Frobenius inside G. And therefore, we can write F as the union of vectors. And now, notice that the case of the neighborhood is contained in GK, because by definition, GK is the kernel of P to the K. And P to the K is divisible by F to the K. Whatever F to the K is also by and so we can say that the FK is the same as G, the kernel of the K power inside G. And last time I formulated the lemma, which says that this group scheme is space. I think good. So we have the following situation: our string F is of the increasing sequence of groups. The kth term of this sequence is kth mu, and clearly the term number k is the kernel of the of f to the k inside From this description, it is clear that have looks locally like formal polynomials. So if we believe in the lemma last time, then the characteristic case is obvious. Well, the reason, in fact, this argument also shows that in this completion function can be scaled off as follows. So for each n, you have a so first of all, in characteristic P, in addition to small infinity, you have small n. You can do that with over function. From external architecture again, right? And then we get intensely looks. So you have these functors, and these functors are compatible with the truncation function from just one to n. And this completion functor is just the limit of this functor of these functors as n goes to infinity. So in general, a general phenomenon is that in characteristic P, various notions are truncated. They have they're defined not only for infinity outside of characteristic P. This is at least not true. Now, let me formulate some exercises. Condition. The solutions to this exercise can be found, for instance, in Rothenberg's lecture. The first exercise is as follows. Almost suppose that K is a field. This is let T be a multiplicative ring. And let be G0 be a simple connected point. Well, this is in the connected component containing the. So we have this sequence. Is R, and this is the maximum effect. Now, there are two statements. First one is that the effect is the same as and this is critical. And the second statement is also easy. Is that both the hat That are visible. And the heights are, so to say, incremental result of the height. The height plus the height. Yeah. Because the height of this. This is rather easy. Another exercise. This follows. Let's let's that from the honest. Suppose that the test then for each for the test we have three numbers. We have the height. We have three divisible groups over the field of test. And one asks, how do they? So we have three functions of the x. And one can ask what is the nature of the function. And of course, for the height of GS, we know that this is the constant. Now, the exercise says that the height between approximate continuous. The other one. And maybe another statement is the following. So that is invisible. It happens formal. One can ask whether formal proof is invisible. The answer is that this happens if and only if the height is infinite. Note that equation from the direction is don't forget it. It's the group. It's the height. There is a movement from left to right is the other direction. And let me give a hint about the previous statement. There are actually two statements here about the height of the height formal. Of course, they are quick. My understanding is that one has to first state about the height, the statement about the formal of the form. Finally, let me mention that the height of the formal part doesn't have to be locally constant. For instance, let us think about the well-known situation when our indivisible group comes from the literature. Suppose G is the indivisible group. Look at E. Well, then we understand how this becomes. Right. There are two types of elliptic curves. There are singular elliptic curves and all the rest. And in the super singular case, there is no entire part. Therefore, the height of yes, and of course, in the case of the height of the indivisible group of the elliptic curve equals 2. So in the super singular case, the completion has 22. In the ordinary case, the entire part has height 1 and the completion has height 1. So if you think in terms of steps, we have to map from this completion function provides morphism from the stack of indivisible groups to the stack of all formal groups, not of formal groups of fixed height. The height of the formal group can vary. It is at most, it's not greater than the height of the indivisible group, and it at least equals the dimension of the indivisible. And finally, so as I said, my misconception was that the theorem is almost full. In fact, it's well, maybe not quite full, but much easier if the height of the formal part is a locally constant. In this case, life is much easier, and in his original work, Tate considered Artinian ring. We assume that R is an Artinian ring, And in this case, the spectrum of R is just a so message have something to overcome. Okay. Now the next topic is something which is called the laws in the now uh, there are two names here, I. Well and Thomas Zink, and the order of the names is alphabet. Maybe this is what it's called Zink Wow diagram. Anyway, first Thomas Zink technique, and then I allow and the joint work, so this is complete. But this is some fundamental diagram of stats, which we have to keep in mind, and we will discuss it. But before introducing the diagram, let me introduce some notation and convention. Well, the main convention is that from now on, all stacks will be theoretically completed. So from now on, and so, we first define the n as a stack over. So now on, I will always work with the theoretic completion of this step. And if you define a relation about just right, I will need the form of condition. And the equivalent of this is the following. We will as test. Now the test in R will always be a single field code. So we will consider R only in the R is given. Sometimes I will forget to say this. Even in this case, it is now one more notation will be the reduction of n to P is given by n by. This reduction, of course, it's union with respect to all possible heights. But suppose that the characteristic will also have a second invariant. Now, since you have this, so if you see the reduction of the P splits into the joint unit, and since you can now really very confusion, we also have now this look at the completion of that. The completion of this, and you can feel it. And here, and this works over any field in R, except all the things are assumed to we have this one. But the field characteristic P we also have n-Truncated. Of the n power. Now, if you fix so if you fix each number, and then you get your hormone groups of dimension B and the variable height. The height is is always now now let me write I will just write the sequence simple from the network, and then I will without really explaining the meaning of the of all this thing. Then I will start explaining the meaning of simple but not full. So there are two versions of this diagram. One of them corresponds to the case. So the original diagram was when n equals infinity. And in this case, we don't have to restrict to characteristic. But if we are into P, then it has the diagram has n-Truncated. Over a mixed form of what is also a factorization of prism follows. This stands for the step of this place. And this is the black box. The main property of the step of this place is that it's very explicit and understood. All the rest details may be important details, but the main thing about the step of display is that it's very understandable. Here, over 50, but also has the truncated. And these are factorizations, the more physics written, the lower left. So maybe I could also for this next. This was the coast. It is supposed to represent German, the capital Germany. And I'm using the letter Z in honor of Z. Since notation was okay. Now I borrowed phi from their work, but I can reveal you this physics notation for Z infinity was bit, which seems abstract now because the map here neither the source is nor the target is. There is a historical so in a certain situation which was of particular interest in the first world, I think they got not only a form of book, but indivisible. And for this reason, he denoted this, and everybody denotes this concept by PT, but I find it's impossible. Very also, so let me know before here I write the bar to denote that we consider the reduction module. In the case of n, I don't write the bar but it has a place U. Without outside of characteristic P, we just don't have stack of and so keys which will define and similar there is a similar story for this way. So I don't write the bar because as far as I know, this thing of finite M is simply not defined outside of characteristic. Now, as I said, this is the step of displays, and the main piece of information about this step is that it's very explicit. It's defined in terms of very explicit linear algebra, more precisely semi-linear. Semi-linear, but maybe the caveat is that it's a semi-linear algebra over not over the ring itself, but over the vector. And the word semi-linear refers to the weak vector problem. And this explains why we cannot define the n-Truncated version outside the characteristic. The reason is that outside the characteristic P, we have only Frobenius SNF from Wn plus 1. But in characteristic P, the weak vector Frobenius is equal to the usual characteristic P Frobenius. And because of this, you have this morphism from W and to W. So this is the reason why this M is defined on the now one, but of course in characteristic P we have infinity, and so in characteristic P, the upper diagram is equal to the index limit in the lower. And of course, I forgot to say that we have truncation motion from n-Truncated. Now, let me say some more general words about this. Well, the key fact of life is that Pn the morphism on perfect values, if K is a perfect field. But then this is the number.
We didn't keep the date, but just
Well, originally, it was not a field, but then the other thing that it was and if we wish, we can use its information to reverse engineer the definition of this. So actually, well, at least it is a perfect field, then the classical Gibbonese theory gives a description of the fluid of k-valued fields from the BT. But then if you look at this description, then you can try to guess how to define, you can try to guess the description of BTM in terms of linear algebra based on Gibbonese first of theory, and then you can try to see whether you can formulate a conjecture description without this unit. And then you get some kind of answer. This answer is however, it turns out that in general, without this universe, you do have morphisms like this. But they are not as, and this is a very important factor. In other words, the effect of life is that we must make guess about the description. Well, the guess about based on many theory gives slightly wrong. Okay, now let me say a few words about the construction of these things. Nature. Okay, yes, of course. Your question is very. So on BT, you have called Cartesian. It preserves the height and it replaces d by h minus. Now, I didn't define the stack of displays, but maybe I remember that I said that this is called the stack of displays. So anyway, for displays, you also have some kind of duality. So the left part of the diagram is compatible with Cartesian. But the right part of the diagram isn't. And in fact, well, because if you wish, say that well, my original intent was to write the program. Because after all, we can instead of passing to the completion, you can first pass to the completion and then pass to the finish. But then it's okay to writing a product is okay if you think of these things only as steps of bookwork. But if you think of them as steps of categories, then one construction is coherent and the other one is caution. Because the so I decided not to write. But anyway, you are right. That's also something that we take over time. And maybe one more remark is that the left part of the diagram is in some sense more important because it is probably chivalrized. In my first lecture, chivalry as well. Chivalrize is the adjective chivalrize. So, well, I would say that the T, first of all, DT, this definitely has an analog, shouldn't be an analog, and that's written in the book. DT has it a Sumerian analog in some sense, mainly in my this year I put 3D prints and in the first print I give the kind of pre-definition of Sumerian organization, which still has to be justified. But at least there is a definition. And in the third, if you don't mind, I discussed the most elementary case. It's more the third things is intended to be very and the morphism C, well, it's not quite, and except if n equals 1, it's also described in general, no, but I think I can define. So anyway, the left part of the diagram is conjecture with Samurai. But this is probably the let me see a few words about the construction of P and Pn define using the so-called line. For perfect field, it amounts to the usual recursive and this crystalline determinant theorem is certain utilization of the classical one, which was a program suggested by Vladimir in 1970, and then several very people worked on this program, achieved some of the goals, but not all of them. Now, the good news is that we are going to have a talk this function. After I finish my notes, Shukotik will give two talks. One of them devoted to crystalline development. Maybe it's first classic for people who feel that And in this theory, you have to assume that all these things are immutable. It's a fluid dynamic. On the other hand, the construction of n not n, but it's infinity. It's defined for n less than r. It doesn't have to be finite. So it's just a general construction. If you given a certain type of similar algebra data, the acceptance, you construct a formal, and it works for any ring, maybe assuming that it's an algebra. And actually this construction, the construction of V is well, it's at least it's very close to the Cartier's theory of formal collective formal. Which also works in this general without the feeling that are okay. Now, maybe now it's time to take a break. We're going to the 5 minutes break. So after the break, I will formulate a theorem proved by Vladimir in his paper published in 2006. His paper is posted on the seminar. And this Lao's theorem describes the nature of the morphism N. It tells you to what extent how it fails to be an input. And maybe another piece of information is that eventually I allow the given input. But now we're going to sort of cycle. Okay. I was asked to explain more words about what I mean by summarize. Well, the expectation or expectation to start and this is for we're supposed suppose we have me left without it. You know, be a minuscule context. the word minuscule really means that if you, instead of the action of the end, on the algebra, then all the weights of the GM are not greater than 1. If I formulate the definition of minuscule this way, then I can even drop the assumption that achieve the double. But the most interesting case is when she is deducted, for instance, of type instead. Okay. So now, given such a view, we would like to have an analog of the morphism Pn in characteristic P, and if n equals infinity, then we would like to have an analog of this morphism even outside. Now, and the expectation of the desire is that our old diagram responds to a particular case. If P their age, and if mu is the fundamental weight number D, then we accept to get the profile. So that was an attempt to answer a particular question. I don't know whether I have.
I received a thanks from you.
Okay. Yes. So, but let me now describe something from the picture. The picture from which is mostly written paper published in 2013, something well sync, and there's a small contribution by me. Now the picture is disclosed. So we have this. So he says something about the morphism Pn, and I will assume that M is finite. The drawback of this assumption that then the calculating is the P, but the advantage is that in this case everything is finite dimension. So a finite type and so on. And because of this, it's harder to make mistakes. So this theorem, the following. It says that the morphism is it's the theorem. Which I remove by now. The group scheme is an n-smooth set of this. And moreover, this group scheme has rank D times H means B, which means that it's smoother with E with M times D times H means. You see the formulation, the theorem involves the words germ and that. In a few moments, I will recall the meaning. Don't be maybe before discussing this, let me make the following statement. So you see that there is this number. Maybe even before this. So talk about section. Second, it's banded by a community groups activities. This group scheme is n-smooth. In particular, it's final of the three our okay. And we know that what rank some people would call it image. The definition of rank is the order is always e to the n r or some r. This r is called my original intention was to call it dimension. But the problem is that I want to have a similar motion for cosine and cosine, which I'm going to do and see. For cosine, it's only dimension. So I thought to call it that. But anyway, forget about the words. This is the order. Maybe one more piece of information that if you look at the word by love, you will not see the word chirp. You will not see the word that. But one of the theories here production says precisely. And of course, he doesn't introduce the yes, and also he doesn't introduce any notation of name. Okay. And also, well, once you have such a theorem, you can ask what it is. And how to describe it explicitly. So the theorem gives the definition. So it says that such a group is, but it doesn't give a description. question about the description is meaningful because this is a group scheme on the stack of n-Truncated displays, which I didn't define, but the main property of the stack is that it's very rather mysterious, somewhat mysterious text on a very explicit stack. One can ask what. I think I know the answer. I think I can prove it for the first time, but it's not for. And before discussing the verbs change, word, and abandon, let me discuss this number. This statement, this number, is summarized. So as I said, the hope is that this morphism should have an analog which image the full linear group is replaced by let's set it up with the minus 2 conjunction. And if so, then what will be the analog of this? Well, a way to think about this number is of course that the page and in the group you have the subgroup by this form and using block. So here is one really means block matrix, but the blocks starts and H final. And then we speak of the group of such matrices as states. Dimension. This is the important parabolic. More precise, moreover, this parabolic corresponds to minus 2. So everything is Schindler. Okay, now I have to explain the meaning of the meaning of the words job and band.
In that case, B.
What?
He was a B.
Yes, minus 2. Well, minus 2 in the reduction groups, minus 2 is equivalent to U being a B. This is one of the equivalent.
Something more precise, like
Okay. So in the question, the answer is that yes, I have something like this. I can tell you where to. Well, please indicate. So this vowel, the group vowel depends on G, but it also depends on M. And if n equals 1, then I define explain explicit. In the first of in my first print published posted this well, I give an explicit definition, but then you can ask whether the case when she is the group, the group of one defined in the C print of one is equal to the group one, which comes from Gauss only. And this is formulated as a conjunction. This equation of mine. Now I can prove this. However, to prove this not available. But it's almost available. However, one can ask what is the group scheme depends. So here in the public, well, I know that the answer, but it's not available. And I'm not going to discuss it. So, I have to discuss the meaning of the words job and then. The meaning of the word job is as follows. Means that locally on this, our morphism looks specifying M which after to that is isomorphic over S. With the classifying state is stack this is the equivalent formulation of what it means to do. Now, the next question, suppose that we have this situation, suppose we have a stack over some X, which is isomorphic to the classifying set of some groups. Question is, can you recover the group scheme from the classifying set? And the answer is that in general, this is not quite possible. Namely, in general, so here I'm recalling some foundational. In general, the group scheme, well, it's if it exists, then it's any such group. Suppose you have two such groups, then this kind of prime. Both are moving in the so the good news is that in this case they are isomorphic locally. And the bad news in general is that this isomorphism is not unique. It's not defined up to uniqueness. It's defined up to isomorphism, which is unique up to internal. However, if gamma is commutative, then life is good. Then gamma is canonical construction. This is very similar to the situation to the fundamental. If you have a connected space, then there is no fundamental group, which depends on the choice of the base. If you have two bases, then a path, commutative class of paths determines an isomorphism between the corresponding fundamental. But if you change the path, then in general you get a difference. They differ by internal isomorphism of the fundamental. However, if the fundamental group is commutative, then we can forget about the base function. So here, one of the statements is that the group scheme in question is commutative. So therefore, although the word church just means that exists locally, however, since it's determined by the self-accepted harmonic, then we see that this group exists not only locally, it descends to this. And it's this group scheme of this, which I call the loudest. Maybe, although fortunately we don't need this definition. Remind us of in general, if you have a jerk, then it is banded not by a group scheme, but by a certain rather ugly object, which is called, I think, band. French is called again. But in the commutative case, we don't need this. So as you see, this it doesn't tell you about how loud and looks, but Lau managed to prove the properties stated above, with one exception. So the theorem is formulated by the cloud and is and smooth. And he only proved that that it is filled by the n power for the. And if n equals 1, this is the same as being in general means it's smooth. Okay. Now we think it's. I think we should finish. No, not quite. So there is also one interesting thing about this picture. One can ask what happens when n equals infinity. Then, the good thing about this infinity is that then you don't have to however, in this case, dealing with steps. And so one has to be very. However, one can at least there is the key. At least let's consider the prepare on infinity to for safety. Let me put which means we reduce this. If you make this assumption, then this morphism for this morphism. If you make this assumption, then this morphism is obtained from the morphisms studied by law by passing to the limit. And so we see that this is also. No. So infinity r is obtained as follows. So first for fixed n, we can do back to the morphism. And r go back. And go back. And the limit is low. Oh, nothing. Now, each of the for fixed n will have a finite group. Is the and then we form the projected limit finite group is so if you pass to the point. What are the things this means? Take the inductive limit of a certain finite related projective. And then of course we get a flat. So this is a flat. Now, an important fact of life, that's somewhat surprising, is that some of the fibers of the good schemes of these well, this doesn't contradict as a an induction. If you have a sequence of finite generated non-zero finite generated modules connected by some, then of course the inductive limit is flat. Some of the fibers could be, and it's important that in this case, some of the fibers are zero. And it's known actually when it started. So the status which are zero, which are the situation is four. So, as far as the points are, well, as far as the perfect value points are concerned, this is very different from BT. So, so instead of so now the question is how to have a irreducible group. Then you can see the performance. Now you can ask whether the fiber flow whether its point is zero or not. And the answer is of course. So if the irreducible group has trivial ethyl R, then the fiber is if the Cartier dual has the trivial ethyl R, then the fiber is also. No other cases the fiber is not. One cannot describe it. Yes. And this is a little bit, and it's important, and actually this is believable. It's believable if you look here. Let's look at this composition. Let's look at the morphism of infinity to the set of formal. In general, it's forgets. However, if our irreducible group has trivial ethyl part, then its formal completion is no different from the irreducible group itself. And this is true not only if you are over a field, but also it's true that for elements. So the claim is of course, so here we have the closed group. Wonderful. Irreducible groups with trivial ethyl. And you have a finish. Now you can complete each of the two steps along this closed subsets in the course sensitivity or the reduced part. Define at that point formal, you can talk about formal completion. Then is this composite morphism it becomes an isomorphism if you restrict to this formal condition. Which is very easy after this, it's very easy to believe that true that all morphisms, all the morphisms were low. It's in diagram as the morphisms if you restrict this. So I have a feeling that this argument is used from the okay. So that's it. And I could finish my series. So I haven't discussed it. If you are interested, you could have a look at the first and third reprint. The third reprint is supposed to be very difficult and very definition there. And then it has the first thing, which is not technical. Now there are some organization. So first of all, there is, as I already said, that this the next two talks will be by model. And my understanding is this will be this first talk. Now, and this will be another piece of information is that I now will give a talk, this 2013 paper, and presumably he will give it at the end of November. But maybe if prefer to, well, this we decided that we would speak at the end of November because there will be a time in November when I will be away, and also there will be a time in November when there will be a workshop that I thought that also I told him that Thanksgiving, other than the Thanksgiving. So, assuming all this, we came to the conclusion that this is given in the end of the day. However, if you tell me that, for instance, it could be more convenient, maybe it's okay for him to speak during the Thanksgiving break, let's say not during the Thanksgiving. And maybe this could be more convenient for some. This is, I can ask him whether this is okay with him. Of course, I don't know that. So this is one. So the drawback of this timing and that is that the interval between our description work. This talk is more than that. However, if he speaks during Thanksgiving, then it's not much better. Here I need your instruction. This is the first organization. Second organizational question in this form. So I didn't give the definition of this thing. I just told you that it's very expensive. For my today's talk, the precise definition is more or less correct. However, maybe it would make sense if somebody volunteer to give a kind of educational talk about the notion of this. And I'm thinking here not about the talk which involves tools of theorems, but rather just discussion of definition and maybe formulation of something. This could, if there are, this could make least for me, it's difficult to absorb a lot of information during a short period. In principle, it would be somewhat safer if somebody gives a kind of introduction or about the notion of explain sometime, let's say, November, before Laos. If somebody volunteers, then I could give some, I can tell some references and make some suggestions to the speaker about what topics if it makes sense. Another approach would be I could give this thing. I could send an email to everybody with the same information, like particular pages, particular paper, and to get accustomed to the notion of this thing. This notion was introduced by Thomas Singh. It's useful at least for our topic. If somebody is interested in things like groups, formal groups in the land, then this notion doesn't. I'm not saying that it's it is 100% necessary for everything, but it's better to. And okay, so I think I formulated two questions. So let's start with the first question. So should we keep the arrangement that I speaks at the end of November, or should I ask him to speak sometime during the Thanksgiving? I don't. I'm not sure that's key because
if the more time to talk something.
I think my impression is that he's thinking about it. However, first of all, maybe he's being thinking. Whatever he thinks, I'm not sure that. So here, they usually ask him questions during. I'm not sure that he thinks this. There is a chance that he will need more than. But just yes, but maybe what the other. I think for different people, Thanksgiving means and grapes and celebrates mean different. For instance, no, Thanksgiving is Thursday. So of course, this particular Thursday has to be. What other things? What? But also since it's a Zoom talk, we are not required to stick to Mondays. We can, but this is so Monday will be fine. So what about Friday or. Did you want to say? So Thursday has to be excluded, but other days would be good. But then there is I don't know what whether he can speak. I can. Now another question is about a possible talk about the motion of this. You would like to.
I wouldn't like one thing.
Very. So can you send me an email? Sure. With that. Do you already know something about them?
A little bit.
Very good. So then please send me an email.
But I'm away for the PI workshop, so it might have to be before then.
So for instance, if you will be away during the periodic workshop, but for instance, during the week when I will be away from November the 7th to November the 4th, and moreover, I will be in the apartments. So I cannot participate in but for instance, during this week, you could do it.
This week?
No, I mean during between the 7th and 14th of month.
Yeah.
Okay. So then please send me an email. Just say that you are ready to give a talk, but not on certain. Very good. Are there any questions?
So the first is because of this allow to display and read. Then you have another map from display to another screen. So is that
Yes.
so is that obvious from the definition of display or read?
Well, the definition of the display is sort of the manifestly so, and I didn't give the definition, but the definition is formulated in a self-dual way. Moreover, it's formulated in a generalizable way, and from the point of books, we give credit to just to respond to the external performance of the field. So once you have one morphism, you can get the other. The question is how do you define this morphism? Well, this is essentially frequency. And in some sense, it goes back to it's closely related to Cartesian theory of formal. If you wish, you can think about this not as Cartier tells us that is the same as the Cartier model, which means maybe with some edge. And Cartier model is model of the topological ring, and it has to satisfy certain. Now, on the other hand, a display, given this display is some kind of linear out, semi-linear out distribution, as a matrix defined objects. And then given this matrix, you can associate with Cartier model. It's defined by generators and And there are two ways to associate activity. One of them is obtained from the other by applying the external form of the activity. And my understanding is that the word display is due to the fact that this data somehow displays a model by generated. I'm not 100% sure. Do you have another question?
They're actually, they're not, nobody think, there is some book scheme which is flat and it's of zero fibers. If they explain that image, it doesn't.
Well,
It was
so so this flat book scheme is at least in characteristic. It's naturally the percentages the projected limit of finite locally groups. So if you pass the coordinate range, then you have the following you have a sequence of finite regime. Then you consider there are also algebras, but for now it's important. Then you consider the inductive. Then the size of the limit depends not so much on the size of each module, but rather depends on the nature of this one. For instance, if ultimate is inside 0, then you get this. So you cannot write this. No. Yes, but everything else. So suppose, well, if you have the coordinate string of group scheme is an augmented function.
Yes.
So let's look at the augmentation. Then for some point I think it's 0. So anyway, there is no control. So this is a little bit weird because of course it's because at a finite level all fibers have the same size. And the liquid have different size just because the nature of the relation depends. Well, anyway, so I'm saying that if you have a germ standard by a trivial group, it's trivial. So some of the fibers in the north are trivial. But others are. Yes.
Maybe I'm not sure if this makes sense or not, but if you have this strip at the finite level, at the truncated level n, then this means that on a point, if you choose a particular display, say over FP, yes, and you fix a display, then you try to figure out what the Barsotti-Tate group is. Yes. But that Barsotti-Tate group has some extra automorphisms that the display doesn't.
Yes. And yes, and I can tell you what this automorphisms is a very good question. And I gave a certain answer to this question in the second print we published this. As this print doesn't contain even conjectural description of the books, keyboards, fibers, but it's in terms of display. But it gives an answer to your question. The answer to the second was truly with a good so there's so maybe there's at least two ways. Answer. Now, question, look at the automorphism of this and what I want to describe a certain subgroup. The subgroup will describe as a group, and the claim is that this group is equal to the group of when you have a morphism from BTN to this, you can ask it. So the group of all automorphisms is just a group of automorphisms of absolute automorphisms. But one can ask about the group of automorphisms inside the fiber of this. In other words, we can ask about the kernel of the map of the automorphism. So the answer is an automorphism here, and the answer is that you have the kernel of the n-power continuous acting in this. This is a kind of textbook answer. But one can make it a little bit more concrete in the following. Now, indeed, since it's a BTN group over a base with the key, with the canonical group. Which is affected by all of them. Now, it's not hard to check if you have an automorphism filled by the nth power of Fresenius, then it has to act clearly on the first and third sets. So now we write the answer is as follows. So as we understand automorphisms which can be there. First instance, third time, formula to them all, name its form from Q. Yes. And we need automorphisms which are in by the nth power of the elements. inside this, I consider now this answer looks complicated, but somehow it turns out that it is much more complex terms. Well, I can explain the answer with so here we are talking about. First of all, the good thing is that the answer. We can forget about the coach. We care about the groups, and the third group is n group smooth, and the second group is instant. And also can. Now we know that one scheme group schemes, let's say, a field are described by the following. A data space equipped with a linear index. So we have so each of these two groups is described by this data. Each of them has also vector space to the linear index. Now what we want to construct, we want to construct the fiber of the round groups. And as I said, log n is smooth. So log 1 is 1 smooth. So as an output, and we again want to get a vector space equipped with the linear index. Now, so we need a procedure, even two vector spaces. If we on the linear index, we get a third vector space. And the answer is that you have to test. So we have these two vector spaces have dimensions with the list of the dimension D. And this one has dimension H. When you tensor them, you get a vector space of dimension D times H minus. And this is the number that appears in logs. So here, the interesting thing is that one smooth, I would say one whose looks is form a tensor, which is not so clear, but it's clear from and my hope is that and smooth and cool smooth schemes also form like a pattern. And moreover, commutative form of this probably form of concept. But this is kind of this is not really worked out. So,
this group scheme, in the sense it comes from the product of and times 2 to small number, where they pull back. So it's actually standard. It comes not from display, but goes down.
yes, this is true. Yes, the group, as I said, this is indeed true. And indeed, I didn't include. Probably. Actually, I don't. I don't expect this. But, there are other directions. Okay, so the next one will be given by.